All right, this is our last lesson in chapter 5, and it is parts of similar triangles. So the first thing we're going to look at is proportional perimeters theorem. It says if two triangles are similar, then the perimeters are proportional to the measures of the corresponding sides. So if our triangles are similar, which means their sides are already proportional, then we know that their perimeters are also proportional. So for our first example, let me erase all this. All right, now, still not working. Okay, so it says if triangle ABC is similar to triangle XYZ, so A, then B, then C is similar to X, then Y, then Z. AC is 32, A to B is 16, B to C is 16 root 5, and XY is 24. We have to find the perimeter of triangle XYZ. So we have to find the perimeter of this triangle. So we only know one of the sides because remember, to find the perimeter, you have to add up all the sides. So we just need to make a decision. Which triangle do we want in the numerator? So I believe in class we did triangle ABC in the numerator, so we'll continue to do that. So ABC over XYZ. So I'm going to go ahead and pick our sides. So I'm going to do 16 over 24 because I know the left side of ABC, so that's 16, and the left side of triangle XYZ is 24. Now I'm going to set those equal to the perimeter of each triangle. So if I find the perimeter of this triangle, it actually ends up being, if I had 16 plus 32, I get 48 plus 16 root 5. Now you could change that to a decimal if you want to. I'm going to go ahead and leave the radical in there and I'll change it to a decimal at the end. So the perimeter of triangle ABC is 48 plus 16 root 5 all over, oh no, I don't know the perimeter of triangle XYZ, so I'm just going to call that a capital P for perimeter. All right, so to solve this proportion, we're just going to cross multiply. So we get 16P is equal to 24 times 48 plus 16 root 5. So 16P, distribute everything. I get 1152 plus 384 root 5. So then I need to divide everything by 16. So that means I have to divide each of those terms. So if I take 1152 divided by 16, we get 72. And if I take the whole number, 384 divided by 16, I get 24 root 5. So we can leave our perimeter in that form. So we can say the perimeter of triangle XYZ is equal to, it's equal to 72 plus 24 root 5. And if we do multiply by the radical and then add, it's approximately 125.67, whatever those units are, because they didn't give us any units. All right, so looks like you have a your turn next. So you pause the video, try the your turn on your own, following the same example, and then come back and check for the answer. All right, so for this one, again, they told us that the two triangles are similar. We have to find the perimeter of P and O. So I'm going to go ahead and put P and O in the numerator. And then I'm going to put XQR in the denominator. So we know the left side of both, so that's going to be 6 over 20 is equal to, I don't know the perimeter of triangle PNR, so I'm going to call that, I don't know, I guess I'll just call it X even though there's an X in the problem. Divided by the perimeter of this other one, 20 plus 20 is 40. So that's 40 plus 20 root 2. So if we go through and cross multiply, we get 20x. Then in this step, I'm going to cross multiply and distribute the 6 all at the same time. So 6 times 40 is 240, plus 6 times 20 is 120 root 2. Divide everything by 20. So we get 12 plus 6 root 2. So we could have, that is our answer. If we wanted it in decimal form, it's approximately 20.49, but they have radical form, so it looks like it is C. All right, so we have a couple theorems here. So these theorems tell us if we have special segments in triangles. So if two triangles are similar, then the measure of the corresponding altitudes are proportional to the measures of the corresponding sides. Now remember, altitudes are just the height of the triangle. The second one says if two triangles are similar, then the measures of their corresponding angle bisectors of the triangles are proportional to the measures of the corresponding sides. So remember, an angle bisector is a segment that splits an angle in half. So it splits into two equal angles. And finally, if two triangles are similar, then the measures of their corresponding medians are proportional to the measures of their corresponding sides. So the median segment goes from one vertex to the midpoint of the opposite side. And notice how they have those two slashes there to show us that that side is split in half. So our next example, it says in the figure, triangle EFD is similar to triangle JKI. It's telling us the EG is the median. So therefore we know that segment and that segment. So D to G and G to F are congruent. And it says JL is the median of triangle JKI. Oh, they put JL, JK. I really think they meant this to be an I. All right, so the larger triangle JKI. So we know the I to L and L to K, they are both congruent. So we have to find JL. So let me highlight the segment we need to find. We need to find that segment if, now let's label everything that we know. E to F is 36. E to D is 18. J to K is 56. All right. And I know E to D. The E to D, I just realized in my notes, we have it corrected. That should be E to G. I was going to say it's almost impossible to find J to L if we don't know E to G. So let's go ahead and change that. E to G is 18. All right, this looks a little better. So now we can do side over side equals median over median. So I'm going to do triangle JKI up top. Then I'm going to do triangle EFD down at the bottom. All right, so JKI will do 56 over 36 equals JL, which we don't know, so I'm going to call that X over 18. So if we go through and cross multiply, we're going to get 36x is equal to 1008. Divide both sides by 36, and we get the x is 28, so therefore JL is equal to 28, whatever units that is. All right, so take a moment, pause the video, work on the your turn. All right, so for this your turn, it told us that it's an angle bisector this time. So MO is the angle bisector, so they already told us those segments are congruent. We have to find x, which is the length of M to M to N. If AC is 5, AB is 7, and M to O is 12.5. Notice how they gave us corresponding lengths. So this time I'm going to set up a little bit different. I'm going to do 5 over 7. So I did angle bisector over right side is equal to now the angle bisector of my other triangle over the left side. So do this, cross multiply, so 5x is equal to 87.5. Divide both sides by 5, we get 17.5. So that is correct. All right, moving right along to our last example. It says the drawing below illustrates two poles supported by wires. Triangle ABC, so that very big triangle, is similar to triangle GED, which is the smaller triangle to the right. AF is congruent to CF. So this side is congruent to that side, to C. And FG, so this little segment is congruent to C to G, which is congruent to C to D. So each one of those little pieces. Now we have to find the height of pole EC. So we are trying to find E to C. We need that segment right there. So we know We know the height of our entire base A to C. You can see that. And we know the height of the pole. And then we also know the entire length of the span of our smaller pole, and we have to find the height. So we have everything we need to set up our proportion. So I'm going to do ABC up first. So I'm going to remind myself ABC's up top, GED is in the denominator. So I'm going to do 30 over x equals 80 over 40. And some of you might say, hey, 40 is half of 80, so whatever x is should be half of 30. So if we're thinking about it, our answer should be 15, but let's cross multiply to make sure. So we get 80x is equal to 1,200, and x is going to equal, if you divide that by 80, 15. Amazing, we were right. All right, so take a moment, try this last your turn, and then we will meet up. All right, so I'm going to let you guys read through the problem. I'm just going to go ahead here and go through the work. So 7 divided by x equals 12 divided by 36. Or remember, you could have that 4 different ways. Cross multiply. We get 12x is equal to 7 times 36. So 12x is equal to 252. And x is equal to 21. But it wants to know what the height of the table is. So if I go back, we knew that this length down here was 36. We knew that this top height was 12. We know that this is 7. We know the entire thing from B to F is H. So what we found here was X. So if they want the height of the table, so H, that means I'm going to have to do 7 plus X. So H is equal to 7 plus X. So 7 plus 21, we get the height is 28. Perfect. All right, so the last theorem I just want to go over, it sort of went along with what we were just doing. It says an angle bisector in a triangle separates the opposite sides into two segments that have the same ratio as the other two sides. So I'm going to highlight these for you. So it says AD over DB is equal to AC over BC. So left side over base, right side over base. All right, so that sums